one later on to you. And use this command to display default variables. So there is an example. How many digits can you memorize the value of pi? I can only memorize about 10. So what we need to do, we do not have to memorize them all. We can get them by computer. For instance, we can use a command like this. I said VPA for variable precision algorithm. So this command means we can display pi with 300 digits. So we can give a command like this. And these are the number of pi. 300 digits. Quite a lot. And if you are not happy with it, you can add a 0 after it. 3,000. 30,000. Or even 300,000. I haven't tried more. But I think in a few seconds you will get the results. So you do not have to memorize the value of pi. When you use it, normally the first 10 digits should be enough in engineering basis. Not display. Yeah, there they are. So you can display the value of pi or other things easily. Also, what is the value of E? E is AXT1, and this is a numerical result. And if you are using VPA, and you can convert 1 into a symbolic 1. So we can have 300. So you can immediately find the value of E using this command. So that seems quite interesting to use a VBA command. So this is the first example we can use VPA to display figures. Well, there are two kinds of useful data types. One is double precision and the other one is symbolic. We can go back to that part later on. Apart from these frequently used data types, there are other data types. For instance, we can express strings. This is very useful in program. Strings is expressed, is quoted by single quotation marks. So we can express string something like this. Name equals my name. So you can use this one to express a string. Single quotation mark. It is different from C language where double quotation mark is used. And also we can use multi-dimensional arrays. Matrix is two-dimensional. Vectors are one-dimensional scalars. We can express three-dimensional arrays. And three-dimensional arrays is quite useful for instance, in image processing. If we express a color image in RGB form, we can unfortunately slide like this. Just a statue, something like this. You can use a matrix to represent the pixels in the picture. And you have three matrices of the same size. The first matrix represents the red component, the other one for green component, and third one for blue component. Then we have a three-dimensional matrix, a three-dimensional array. This is a matrix of two-dimensional, and this is the third direction. So we can use three-dimensional arrays to express certain things, so high dimensionals. And also, we can use the style array. I shall explain it later to you when I use them. And the other one is also very interesting, the classes, which is useful in object-oriented programming. I don't know whether you have use the LTI in control, transfer function in control. It is defined in a class or object space, so that if you want to represent a transfer function, you can use a command like this: 1, 1, 3, 3, 1. And this is the transfer function, which is 1 over s plus 1 cubed. So we can express it in an object. And then if we want to analyze such a system, what we need to do is to use both commands to draw the body diagram of it. So that's quite simple. It's useful in object-oriented program. It is slow if you run it the first time. Not here yet. It's the body diagram of a transfer function. So you use that kind of command, you are using the object-oriented programming technique. So you can use classes. You can also define classes of your own and use it simply like this. So there are other data types. So I will explain more about this later on when we use them. Now let's see the